Hey guys, so welcome back to our discussion of lipids. So in section 3, we were introduced to something called triacylglycerols, or more commonly known as triglycerides. These are where we have that glycerol, which is those three alcohols that have three fatty acids connected through an esterification process. So this section in the textbook is called Chemical Properties of Triacylglycerols. In all reality, it's mostly just reactions of triacylglycerols or triglycerides. So let's go ahead and jump into our first reaction, which is hydrogenation. So we've talked about hydrogenation before in terms of just our alkenes back in our chapter 11, I believe, way back in the day, where we just have an alkene or an alkyne, and you add hydrogen to it, and you, with your metal catalyst, and you fully saturate those double bonds to make an alkane. So in this reaction, it's exactly the same. We're going to be doing the same process as we did before. So you're going to take your unsaturated triglyceride. I'm going to put X number of hydrogens because it's however many double bonds that you have in that molecule with a metal catalyst. So you could have nickel, platinum, palladium, same as we had before. And it will leave you with a saturated triglyceride. So you're going to go from unsaturated triglyceride, meaning you have double bonds within those fatty acids in there, to a saturated, meaning you have only single bonds. So if I had this triglyceride here shown, you can see that we have these two double bonds. Remember that most triglycerides are not the same all the way across, or all three fatty acids are not always the same. So in this case, we have two fatty acids that are the same and one in the middle that's different. And then we would add in this case, two hydrogens, and then our catalyst. So I'm just going to put nickel on here. And then you can see that it's going to hydrogenate those alkenes. So where we had double bonds before, now we have single bonds, and the hydrogen is added across that alkene. So where we see this in everyday life is actually more common than you think. And specifically, it's with the synthesis or the production of margarine. So margarine is different than butter, and it's different than butter structurally. So what margarine is they take vegetable oil. So all of you guys know that vegetable oil is oil. It's nice and liquidy. Doesn't really turn into a solid ever. We take that liquid vegetable oil that has a variety of different saturation elements within it. So I just drew an example here where we have lots of double bonds, and you're going to do a partial hydrogenation process. So instead of fully hydrogenating all of your double bonds, meaning all of your double bonds are going to completely go to a saturated system, a partial hydrogenation, they don't let it fully go to completion. So what this does is it takes that oil, that liquid, and they put just enough saturation in it to make it a semi-solid. So to make it that like spreadable margarine kind of thing that you all are familiar with, I'm sure. So you can either have, for example, up here, you can do your fully saturation, so your full hydrogenation. You can do partial, where you can have just maybe half of the double bonds get hydrogenated. Or you can also have something called isomerization. So in this process of hydrogenation or partial hydrogenation, you can actually take those double bonds and isomerize them to trans isomers of your alkenes, and that's where you get what's called trans fats. So you'll see that's kind of the unhealthy version of fat. That's the kind of fat that could cause heart diseases and things like that in our bodies. So that's how trans fats are made, are through these partial hydrogenation processes. We'll go through the other two reactions in our next video.